Jinshan Xiong has been working on Lustre since 2006. Jinshan spent most of his time on client I/O feature development and bug fixing. He specialized on Lustre I/O code, performance, tuning, and LDL, isn't that like cholesterol? LDLM lock. Jinshan Xiong is now a staff engineer at Intel, and with any luck, this is going to work.
Thank you. So today I'm going to talk about layout lock. So this is today's agenda for my presentation. So first of all, I'm going to talk about what is the data layout of Lustre. And then I'm going to cover some requirements about layout lock. And then I'm going to dive into some implementation detail about layout lock. And finally, I'm going to list some use cases of layout lock. Okay, so what is the data layout in Lustre? So data layout determines how to place your data into OSTs. This is because in Lustre, we usually put your data on multiple OST to fully use the network and the disk drive bandwidth. So it's pretty important for you to know the data location so that you can find it back later. Right now, the layout is stored as an extended attribute on the MDT object and interpreted by the LOV layer. So let's take a look at the picture. So the blue line is the metadata path, and the red line is I/O path. So first, the layout has to be fetched from the MDT side to the LOV, and in this case, if application issues an I/O, it will go through LLite object and then go to LOV object. At LOV object, it will be the I/O will be split by the layout to multiple OSC object, and then finally go to OST object. In Lustre, the only layout which is supported is RAID 0, and which is immutable after it is set up. Okay, so why do we need layout lock? Because we do have the requirements to change the layout. Usually, we tend to cache the layout on the client side because otherwise we have to fetch layout from MDT for every single I/O, so this is not acceptable. Okay, so there are a couple of features, new features, which we need to change the layout on the fly. So the first one is HSM, which is the major motivation of layout lock, and then replication, and then data on MDS, and then restriping, also known as migration. So I'd like to mention replication, especially because this is a very important feature to let us deploy Lustre on commodity hardwares, and that means we can use Lustre in cloud computing. Yeah, that's pretty hard right now. So layout lock is a fundamental feature for all of the data placement features if they want to change layout. Okay, so in the next few slides, I'm going to cover some implementation detail about layout lock. So layout lock is an IPs lock which is managed by MDT, and on the client side, layout lock is required to cache layout on the client. That means if the layout lock is revoked by the MDT, the layout will become invalidated. Actually, we don't want to reconfigure the IO stack for each losing of layout lock. This is because we have to clean up everything, for example, caching pages and caching logs to reconfigure IO stack, and this will be time-consuming and sometimes unnecessary. So instead, when we lose the layout lock, we just mark the layout as invalid. So right now, I/O will depend on a layout lock. That means before each I/O starts, we have to check if the caching layout is correct on the client side. If not, we are going to talk to the MDT and to fetch the up-to-date layout. Also, a compatibility connecting flag is worked out to address the compatibility issue. Layout lock will be supported in Lustre 2.4, which will be released soon. Okay, so layout lock requesting. Usually, the layout lock is picked back by IT get utter or open request. In this way, we are not going to add extra overhead for this extra lock. And this is pretty important for start ahead when we have done a lot of work to improve start ahead performance by Xiong, so I don't want to ruin it, right? Of course, we only pick back the layout lock if there's no confliction on the server side. This is because potentially the layout lock can be held by some process for some special purpose for a long time, and we can't live with waiting for it for a long time. So on the MDT side, MDT object log try is invented for this purpose. So we just try to get the layout lock. If we can't, we just abort it. And so usually for the get utter RPC, we can return three IPs log right now. So it's lookup, update, and layout. If we can't grant layout lock for the get utter and open, layout log can be requested by IT layout explicitly. This is a normal DLM request handling on the MDT. That means it can wait much longer than intended request. Layout can be returned with DLM reply if there's no contention on the MDT or LOVB buffer in the completion AST if there's contention on the MDT. Okay, so I'm going to talk about some tricky case about the layout lock. So first of all, layout lock is an IP lock, but it's mainly used in IO path. So that means we cannot hold the layout lock to do IO to avoid being evicted by the MDT. So to explain this problem, so suppose we hold the layout lock and do IO, and if some of the OST is unreachable during I/O, and meanwhile the layout lock will be cancelled, will be revoked by the MDT. So what will happen? Okay, so the client will be evicted because it can't cancel the layout lock on time. So this is not acceptable. The consequence about this is that layout lock can be lost anytime during I/O. But on the other hand, we have to make sure the layout is correct for the I/O. So they are contradictory by themselves. So this is very tricky, and we usually need some extra mechanism to make sure the data model is correct. So I put a stop here. If you are going to use layout log in your project, so you have to think about it carefully to make sure you are doing the right thing. So, but of course, I don't mind if you like to talk to me first. Okay, so let's take a look at the I/O handling with the layout log. So first of all, so I/O init, and then before actual I/O starts, we have to make sure the layout is correct. By doing this, first of all, we check if there's a correct layout log on the client. If not, we have to talk to the MDT to request layout log and, of course, up-to-date layout. And then actual I/O will be performed to send data to OSTs. And after this, layout has to be verified, and we are going to check the cache of layout log again, and if not, we'll have to talk to the MDT again. And if during this time the layout is changed, so we have to restart the whole I/O, and otherwise the I/O is finished. Okay, so I'm going to cover some use cases of layout log. So this is pretty important, and we're going to add a lot of data placement features into 2.5 and 2.6, right? So first of all is layout swap. This is an MDT operations to swap the layout between two files. So usually we use this to change the layout of a file right now. So please take a look at the pictures. The picture on the right is two files before changing layout. So the file, this is right? Oh, this is left. Sorry, just kidding. Sorry. Okay, on the left, you have two files, and the file with blue block is the actual file which contains your real data, and the file with red block is temporary file. So usually this kind of file is created with the desired layout, so that you can change the layout of your original file. So the picture on the right is the file stat after layout change. So as you can see, the blue file has empty layout, but go. Oh yeah, yes, I'm doing that later. Thank you. And the red file will take over the layout and the OST objects. So this actually happened in adjustment release, and the temporary file will be deleted soon, so that your temporary file along with OST objects will be deleted on the MDT side. And during this time, layout change time, MDT has to revoke layout so that clients will be notified by this change. And the cool thing is that usually even opening file handles will not be affected, so that if you have opened a file during layout swap, your file is still accessible. So this is very cool. Okay, so another use case is restriping, also known as migrations. For migration, the main purpose is to change the stripe number of a file. For example, if you add some more OSTs into a cluster and you want to do a space balance, so you want to move some files into another OST pool. And we need to use layout log for this feature. So first, you create a temporary file with the desired stripe count and the desired OSTs. And then we're going to copy file content to the temporary file, and then we're going to swap the layout and delete temporary files so that the old objects will be deleted from the OSTs as well. So from now on, all I/O to original file will be forwarded to the new objects, even the file is opened before the striping. So this is really cool. Another use case is data on MDS. So for data on MDS, we usually store small data on the MDT so that we can benefit from the fast data access, also less RPC. And if the file becomes larger, we definitely want to migrate it to the OSTs. So if this happens, we're going to allocate OST objects to generate a layout, and then we're going to migrate the small data from MDT to OSTs, and then we're going to revoke layout so that all of the clients will be notified for the update of layout. So the next one is replication. For replication, we're going to store the same data on multiple OSTs. So the major challenge of replication is that if one replica failed to write, we have to take the replica out of the layout because we don't want that replica to be read by some of the clients because it will include stale data. So this is what we are going to do for a replication. So client will be notified of this new layout because we are going to take this stale replica out of the layout. And then new replica will be created by the dedicated clients. And then layout will be updated again so that we have 4 replicas for the object. And the last one is HSM. CEA guys will cover this topic for HSM. And layout log is mainly motivated by HSM guys, so thank you very much. And the layout log is needed to restore and release files for HSM. Yeah, this is my presentation. Thank you very much.
We're running behind, but is there a question?
Hello. I wanted to ask you, one of the key features that a lot of people have requested is that not only can you change the stripe count in the migration, but that you can actually control which OSTs all the striping goes to.
Yeah, of course. So usually, for example, if you have a couple of SATA disks in your old cluster, right, and you got some new money, and you want to get SSD OSTs and add them to your cluster. And then you want to migrate some data, for example, your bank account information to the SSD so that you can access it faster, right? And in that case, you can create a pool with your SSD OSTs, and then you can create a temporary file in the SSD pool and then migrate the file. Yeah.
So if the layout is revoked while a client is actively writing to an OST that will no longer be in the layout, so what happens in that case?
Well, so yeah, this is a very good question. Oops. Okay, so yeah, basically look at the stop. So basically you need an extra mechanism to make sure your data model is consistent. Yeah, for example, right now for migration, we are using a group log to make and a data version to make sure the file is completed, copied to the new file, and there's no any active I/O and dirty cache on the other client. For HSM, we're going to use exclusive open to make sure there's nobody else is opening this file. Yeah.
Okay, so there's no mechanism to force the client to stop writing to the old object.
Yes, you need an extra mechanism. Yeah. So be careful if you are going to use layout lock in your project. Yeah.
Okay, we're pressed for time.
Yeah, just one more quick one.
Help yourself and help yourself.
Okay,
Sorry,
so
I
you
got
can
hit.
find me later. Thank you, guys.
I got handed the mic, so.
All right.
Okay, is it done? Or?
Thank you.
Okay, thank you very much.